Welcome to Lesson 28, Solving Equations with Variables on Both Sides. We're going to start off just reviewing some of the steps you would take when solving equations. The first step, as usual, is just to simplify as much as possible first, which means to eliminate any inclusion symbols and combine like terms. But the key here is you only want to combine like terms on the same side of the equation. So if you're going to add 2x plus 3x equals 5x, you need to make sure that both of those terms, 2x and 3x, are on the same side of the equal sign. And we'll go over a couple of examples in a little bit. The second step here is going to be to use inverse operations to bring the variables together onto one side of the equation. And the key word here is inverse operations. If you're moving something from one side of the equal sign to the other, you have to use inverse operations. So you want to be getting all of the variables on one side. So for example, all of the x's on one side, or all of the y's, or all of the m's, whatever your variable is that you're dealing with. And then the last step is to isolate the variable. So we're going to go on to a couple of examples first before going on to those vocabulary words. So the first example here is 8x equals 3x plus 20. There are no inclusion symbols. There are no like terms on the same side of the equal sign that can be combined. So for example, the 8x and the 3x are on different sides, so we can't combine them to get 11x. What we can do, though, is move the 3x over to the other side. So subtract 3x on both sides. And that will give us 5x on one side equals 20. And then the last step is to isolate the variable. So we would divide by 5 on both sides to get x equals 4. And that's our final answer there. Okay, the next problem here. B, we do have inclusion symbols, so we need to distribute. In the first one, it's the 4. We need to distribute this to the 2. So I'm going to just write down 3x because that isn't going to change here. 4 times 2 is positive 8, so that would be plus 8. And then 4 times negative 2x would be negative 8x. And on the other side, we're going to distribute the 3. So 3 times 5 is 15, and then we have an x. And 3 times 1 is 3. So we have plus 3, and then we also have this minus 15 over here to bring down. The next step, if you look at the first page of your notes here, is to combine like terms on the same side of the equation. So we have a 3x here, and we have a minus 8x. Those are on the same side, so we can do 3x plus 8x, which equals negative 5x, and then we still have this plus 8. And on the other side of the equal sign, we have a 15x. There aren't any other terms with x in them, so the 15x is going to stay the same. But we can combine this plus 3 and minus 15. So 3 plus negative 15 would be negative 12. So we have 15x minus 12 on that side now. Okay, the next step is to try to bring all of the variable terms to one side. So we want to use inverse operations now. And I would say the easiest thing to move is going to be this negative 5x because the inverse of that is plus 5x. And it's always easier to add than subtract. So we'll add 5x to each side. And we'll get 8 equals 20x minus 12. And the next step is going to be to isolate the variable. So first we want to get this term by itself. So we want to get rid of this 12, so we can add 12 on each side. I'm going to pick up over here. So 8 plus 12 is going to be 20 equals 20x. And then the next thing to do is get the x by itself by dividing by 20, that'll equal 1. And 20 divided by 20 is 1, so x equals 1. Okay, now we're going to go back to those vocabulary terms on the first page of your notes. The first one is identity solution. An identity solution is, if you remember back to the identity properties, when we talked about how an identity is what you would see in a mirror. So it's kind of like a mirrored solution, or a mirrored equation, which means that you're going to have the exact same term or number on both sides of the equal sign. An example would be if you had an equation that said 10 equals 10. It's the exact same thing on both sides of the equal sign. And what this tells you is that this equation works for all real numbers. All real numbers is a phrase we're going to use quite often. There's actually a symbol for all real numbers, which is an R with a double line going down. So that's the symbol for all real numbers. So let's look at an example. We're going to go to example C in your notes, which is on the second page, and we're going to solve this. First thing we're going to do is distribute the 4. So first we can write down 2x, that's not going to change. So we have 4 times x, which is 4x, so it's plus 4x, and 4 times 3, which is 12, so plus 12. Okay, on the other side, we're going to distribute the 2 to the 3, so that's 6x, and then distribute the 2 to the 6, so 2 times 6, which is 12, so that's plus 12. Okay, the next step we want to do is to combine like terms on the same side of the equal sign. So that means we have a 2x over here and a 4x. So 2x plus 4x is 6x plus 12. And on the other side, there's nothing to combine that's like, so we have 6x plus 12. Now you can already see that we have a mirrored equation here. We have the same exact thing on both sides. But if we continue and we move all of the x's over to one side, if I want to move this term over here, I would subtract 6x if I'm moving it to the other side with inverse operations. So on both sides, this is going to cancel out, and I'll be left with 12 equals 12. So because this is a mirrored equation and it is true, then the solution to this equation is all real numbers. And what this means is that you could put any number in for x. You could plug in any number on the spectrum in for x, and this equation would still be true. And this is what we call an identity solution. All right, we're going to go back to our vocabulary again for just a moment to talk about the no solution. No solution is what happens when you solve an equation and you end up with a false statement. So when all the variables have been eliminated, so in the process of isolating the variable, you actually got rid of it and it canceled out. And the result is a false statement. Keyword there being false. So let's look at an example of that. We're going to look at example D on your notes. So the first step is always to get rid of the inclusion symbols. So we'll start off by writing down 9x, and then we have a minus 5 that we're going to be distributing. So this is negative 5 times 2x, which would be negative 10x. Negative 5 times 1, which would be negative 5, equals, and we're going to distribute 2 times 3 is 6x, and 2 times negative 6 is negative 12, and then we have this 7x as well. Okay, the second step is to combine like terms on the same side of the equal sign. So we have 9x and negative 10x here, so that's going to give us a negative 1x minus 5. And then on the other side, we have a 6x and a negative 7x, which is again going to give us negative 1x. And then we have minus 12. Now you can already see here that there's something wrong. We have a negative 1x on both sides, but a different number being subtracted. So if we were going to move the x's all to one side, we could move this one over by doing inverse operations. So add 1x on both sides. And as you can see, they're going to cancel on both sides, and we're just going to be left with negative 5 equals negative 12. So this is a false statement. So that means there is no solution. It means no matter what you try to plug in there for x into the original equation up here, no matter what you plugged in there for x, it would never work because there is no solution for this equation. Okay, moving on to the last example. A clerk at one store is paid $400 a week plus 75 cents. So that's $400 a week plus 75 cents for each item she sells. So that would be, sorry, my screen's moving. That would be 75 cents times the number of items she sells. And at another store, a clerk is paid $500 a week plus 50 cents for every item. So we'll just use X for the number of items. And the question is, for how many sold items are the clerks paid the same amount? So we're going to take these two equations that represent how much each clerk is paid. This is the first one, and this is the second one. And we want to know for how many items, which is X, are they equal? So we set them equal to each other, and then we can solve. So there's no inclusion symbols, there's no like terms on the same side of the equal sign, so we're going to move all of the x's over to the left. And the reason I'm going to move this one instead of the 75.75x is because this one is smaller, and I know if I subtract it, I won't end up with a negative. So I'm going to subtract 0.5x on both sides. It's going to cancel on the right. And on the left, I'll have 400 plus 0.25x equals 500. And then if I am going to isolate this term with the variable, I need to get rid of the 400, so I'm going to subtract 400. Then I'll have 0.25x equals 100. And then I can just divide by 0.25. So that will be 1. And I'll have x equals 100 divided by 1/4 is 400. And I know that that is representing the number of items. So the answer to the question is 400 items. They'd have to each sell 400 in order to get paid the same amount. And that is today's lesson. Thank you for taking notes and listening.